All right, we're going to be doing some Riemann sums, and Riemann sums are basically they're basically how we got actually the integral in the first place. And so a lot of people learn them actually before integrals. But I think it's a good the way that we learned it because you now know how to integrate certain things, and Riemann sums are it's easier to see the reasoning behind them once you understand integration. So basically, a Riemann sum, we use them, it's basically like drawing rectangles under a curve to find or to approximate the area under the curve. So if a curve right here, like we have in front of us, x squared plus 3, we want to approximate the area under that curve. And we actually know how to do that with integrals already, but we're going to try to do it now with a Riemann sum. So let's figure out what this is with an integral first. So you guys know how to integrate this. This is x squared plus 3. So let's just go ahead and find the integral. Well, we would do the integral from 0 to 3 of x squared plus 3. So that would equal x to the third. Let me get this to work. X to the third over 3 plus 3x evaluated from 0 to 3. And so that evaluated at 3 would be 3 cubed divided by 3, which is 9, plus 3 times 3, which is 9. And then we would subtract 0 from that. So we know for a fact that the area under the curve there is 18. We know that from integration. And so basically that would be from here to here, this area under the curve is 18, right? So it's 18 under the curve, that whole thing. And the integral gives us the exact amount. But we're going to look at Riemann sums to see how we can use them to approximate. And if you actually wanted to count these, if you wanted to look, you could actually count these and figure out that it is about 18, right? So we've got like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then like this one and that one makes 17 and that one make 18. So really, you really do have about 18 squares under the curve, right? And so you could do things like that. But Riemann sums are really handy when we have curves like this one. See, that one's like it's like a non-standard curve. It's one of those curves that you couldn't just write a function for and figure out. You would need another option. And so for something like this, we're going to have to use a Riemann sum to find the actual area under the curve, or the approximate area under the curve, because there is no function that we could integrate here. So let's look at what it looks like on a curve that we understand a little bit better. So here's our x squared, and again we're trying to find this area under the curve, right? We're trying to find this area under this curve. And there's the way that we do that with Riemann sums is we look at rectangles. So we draw rectangles and then figure out the area of the rectangles, because we know how to figure out the area of rectangles, and then that helps us gives us a little bit of an idea of what the area under the curve is. So first, let's draw some rectangles. We're going to do what's called a right-hand Riemann sum. And a right-hand Riemann sum basically, I guess I'll just show you. So what we're going to do is we're going to draw 3 rectangles, and we're going to try to figure out what the area under the curve is using those 3 rectangles. So if we drew 3 even rectangles, we would, they would have a width right here of 1, and then another would have the width of 1, and the other would have a width of 1, right? Okay, so these are our 3 rectangles. Those are the widths. And then the right-hand Riemann sum basically is the idea is that we go from the right side. So what's the right side of this rectangle? It would be right here, right? And so we go up to the curve, and then we go over, and we make a rectangle, okay? And so then on this one, I go to the right side of this rectangle, and I go up to the curve, and I go over, and I go over, and I go down, right? And then this one, same thing. I go up to the curve, and then I come over and I come down. So these blue rectangles are going to approximate the area under the curve. And what you can see on this specific curve is this one's going to happen to be an overestimation, right? The area under the in those blue rectangles is significantly larger than what we're trying to estimate. Well, let's figure out what the area is of those rectangles. Well, the area of the first rectangle, each of them has a width of 1. And so the area of the first rectangle, it's 1 wide and 1, 2, 3, 4 tall. So the area of that is the width times the height, which is 4. And the second one is 1 wide and 1, 2, 3, 4, 5, 6, 7 tall. So that one is 7. And then the other one is 12 tall. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, so that one's 12 tall. So if we add the area of all of those together, then we have 23. Did I add that right? 11 and 12. So the area of those blue ones is 23. So that's a little bit of an overestimation, right? It's a little bigger than 18. So then we think, what if we go the other way? What if we, instead of making them on the right side, right, instead of making this rectangle go up here to the right side, what if we do it on the left side? We go to the left side of the rectangle and go over. So let's look at what that would look like. So we would go to we're going to do 3 even rectangles again. And really with Riemann sums, you can do as small or as bigger rectangles as you want. The smaller rectangles, the better the estimation. So we're going to go here and we're going to go up to the curve. We're going to go over and down. You know what? I think I'm going to use red for these ones so that you can see them a little bit better. So you go up to the curve and then over and down. Then on the left-hand side, we go up to the curve and over and down. Okay, and then we go up to the curve and then over and down. And you see that this one, if you can see the red, I keep calling them triangles, the red rectangles are slightly smaller than the curve, right? So we're actually missing out on all of this, and we're missing out on all of that. And so this left-hand Riemann sum for this specific curve is going to be an underestimation, and we can't ever know one way or the other specifically if it's always an overestimation or underestimation based on whether it's a left or right hand. So let's take a look. Let's see what the area of each of these rectangles is. Well, the first rectangle has an area of, it has a width of 1 and a height of 3. So the first one has an area of 3. And then the second one has a width of 1 and a height of 4. And the third one has a width of 1 and a height of 7. And, you know, I know that because I can count, right? I can count up 1, 2, 3, 4, 5, 6, 7. But I also have a table here on there that I did. This is, it's just an XY table. It shows us when x equals 0, what does y equal on the function, and that'll come in handy here in just a second. So if we add all of these together, we get 14, and we see that it's on the other side, right? So it's a little bit, it estimated it a little less than it really was. So is there a better way? Well, there's one more type of Riemann sum that we're going to look at right now, and that Riemann sum is a midpoint Riemann sum. So I'm just going to go ahead and erase this so it doesn't get too messy. And again, we're looking for this area under the curve right here. We're looking for that area under the curve right there. And Corbin. So we're looking for this area under the curve right here, right? And so the other option is we could make make rectangles that use the midpoint. It's called a midpoint Riemann sum. And basically what we say is, all right, we want 3 even rectangles, okay? And so we're going to have 3 even rectangles. I'll do this one in green. So they're going to have a width the same as they had before, right? A width of 1, width of 1, width of 1, okay? And then what's their height going to be? Well, this one, we're going to go right in between. We're going to go right in the middle of that, and we're going to make the rectangle based on that point right there. Okay, and we're going to go right in the middle of that rectangle, and we're going to make it based on that. Okay, and then we're going to go right in the middle, and you know how great I am at drawing straight lines. We're going to make the rectangle based on that middle point. And you'll see that's actually it's a better approximation because we're gaining some here and losing some here, and we're gaining some here and losing some here. It's actually not a bad approximation. So the midpoint Riemann sum is the third way to do this. And so what does that actually, what does the midpoint Riemann sum tell us for this one? Well, let's figure out the area of each of those three rectangles. So the first rectangle is 1 wide. And how tall is it? Well, this is 1/2 right here. So this is 1/2, right? The midpoint of that rectangle is 1/2. Let me see if I'll do it in a different color for you. 1/2. And then this one, the midpoint is 3/2, and the midpoint of that one is 5/2, correct? So let's figure out what's the actual height at each of those points. Well, the first one, when x equals 1/2, y equals 13/4 or 3 1/4. So I just figured that out so that we didn't have to do that math right here in the video. So that's where I just got all of that right here from my table. I just plugged in 1/2 and it came out 13/4. All right, and then what is the height, the area of the next rectangle? Well, the next rectangle is 1 wide and it is 5 1/4 tall. Okay, and then the third one is 1 wide and it is 9 1/4 tall. So let's see, we have 9 and 5 is 14 and 3 is 17. So we actually get 17 3/4. So that one actually is really, really close. It's actually a really good approximation of our area. And so you can see with Riemann sums, basically the idea is we're going to draw rectangles underneath a curve, and then we're going to find the area of those rectangles, and it's going to tell us pretty close what the area under the curve is. Now there's one more way. I think I have enough time. One more way we could do this. We could make more rectangles, right? We don't just have to do 3 rectangles. We could do, let's do 6 rectangles. So if I had 6 rectangles, okay, so if I have 6 rectangles, there's going to be this rectangle right here, right? And then there's going to be this rectangle right there. And we'll do a right hand one on this one. So we're going to go to on the right hand side of the box and then up. So you see that we could do 6 rectangles. And that's going to give us actually a better approximation than just 3 rectangles. So I won't go ahead and calculate each of those right now, but you could find the area of each of those rectangles and find that you could find the area under the curve with each of those rectangles as well. So again, with something like this, it might seem overkill to do this with a curve you actually know how to integrate. But what you'll see in the next video is that there's a lot of curves we just can't integrate. And so a Riemann sum is a really good way for us to be able to find the area under the curve without having a function to integrate. So we'll go to that one.